Kinetic, no. Thermal properties of matter. Revision.
Up to which part? Completed or left with some portion?
So we did till a waterfall part.
Till?
Waterfall, one question we did.
Okay. That is on a calorimetry part. Okay. So next is heat transfer. In this particular topic, you will be asked to define. First is to derive expression of heat current, or simply heat flowing through any conductor, or heat flowing through conductor. I had explained this particular portion by using the concept of electricity, but you have to define in some other way also. Let me define you how to solve or how to define this part. You will say heat flowing through any conductor will depend upon certain factor. Suppose this is any slab conductor which is maintained at temperature T1 this side and temperature T2 this side, having length L, area of cross section A. So you will say heat flowing through conductor is directly proportional to first temperature difference at its end. Temperature difference of end. Second, area of cross section. Third, time taken. And inversely proportional to length of conductor. So from this part, you may write Q proportional to area of cross section, change in temperature, time divided by length. Now, on replacing this proportionality constant, just put K A delta T small t divided by L. This K is called thermal conductivity. Thermal conductivity. Is it clear?
Yes.
Now move this time to left side. So you'll get Q divided by T is equals to Ka delta T divided by length. This quantity rate of flow of heat through any conductor is also called heat current, H. So you may derive this particular expression like this, which is other than concept of electricity. Now from this part, you'll be asked numerical to find heat current, temperature difference, temperature gradient, and different parts from this segment. Next, you may be asked to find temperature of junction according to combination of slab. Let me give you a question to this part. Temperature of this end is 150 degrees Celsius. Temperature of this end is 20 degrees Celsius. Thermal conductivity of this is 0.5 watt per meter per Kelvin, and thermal conductivity of this is 0.3 watt per meter per Kelvin. Area of cross section of this end is A, and area of cross section of this end is 2A. If their length are equal, find temperature of junction. Find temperature of junction. Samara, how will you start with?
So we'll use the formula for series combination.
Good. So first, heat current in this particular rod, let's say H1. Similarly, heat current for this rod, let's say H2. Since this is series combination, so H1 must equals to H2. Put their values and try to find temperature of junction. Let's say T0. Try to solve. Myra, you got me answer?
No, so I'm solving.
Ruslan, we have to solve temperature of junction in this problem. Just use the concept of heat transfer and try to find the value of T0. Try to solve. Samara, just see how to solve it. According to the formula for heat current is K A by length. Change in temperature, it will be higher temperature minus lower temperature. Second part, K A by length, higher temperature minus lower temperature. Just equate these two terms. So K we have 0.5, area is 2 times of A, divide by length L, temperature difference 150 minus T naught. K 0.3, area A, divide by length L, temperature difference T naught minus 20. A by L will cancel out. 0.5 into 2, it will be 1 multiplied by 150 minus T naught equals to 0.3 into T naught minus 0.3 into this 6. So move this T naught to right side and 6 to left side. So 150 plus 6 equals to 0.3 T naught plus T naught. So it will become 156 and it will be 1.3 times T naught. So T naught is 156 divided by 1.3. Remove decimal, 0. 13 in 1 times 2, 6, 13 into 2. So T naught will be 120 degrees Celsius. Samira, any doubt?
No, sir.
Okay. Arslan, done? Next question will be, you'll be asked suppose in winter, if you touch any metallic body and any wooden body, in which case you'll feel more cold, for metallic case or for wooden case?
Metallic.
Why? It is based on thermal conductivity of those two substances. Since thermal conductivity of metal is more as compared to thermal conductivity of wood, so more amount of heat will conduct in terms of in case of touching metallic body as compared to wooden body. So there will be more transfer of heat from your body to the metallic body. So you will feel more cold in that case. And similarly, in summer season, on touching metallic body, you will feel more hot or simply hotter as compared to wooden body. Same case. Is it clear?
Yes, sir.
So it will be based on thermal conductivity of those two substances which we are touching. Next question will be to find thermal conductivity for series combination and then parallel combination. We have derived K equivalent for series or parallel combination. So these different questions will be asked from this part. In last part, that is radiation, you'll be asked to define different laws and terms related to radiation, just as what do you mean by emissive power? What do you mean by emissivity? Define Kirchhoff's law of radiation. And Newton's law of cooling.
So for me, this Newton's law of cooling is deleted.
Oh, good. Like in some school, this entire radiation part and thermal heat transfer is deleted. So it depends upon your school, how much portion they are giving. So if this term is deleted, so you'll be asked to define emissive power, emissivity, or Kirchhoff's law of radiation. Or there will be question like good emitter are good absorber, and similarly good reflector are bad absorber, these type of statement. Okay, Samaira?
Yes, sir.
So this is all about this thermal conductivity, thermal properties of matter. Next is thermodynamics. In some school, the entire second portion, that is heat engine, refrigerator, heat pump, is deleted. And then be done only process, thermodynamical process. So only definition will come from this part. But in actual, from this chapter, you'll be asked to define different thermodynamical process. Thermodynamical process. Next, there will be some problem or simply question, theoretical, related to process involved. Like I define you why on traveling from one point to another, pressure of a tire increases in vehicle. And if it becomes insufficient, tire often got burst on long drive. Similarly, on bursting of balloon, ejecting air will be cool. Why? These different things. Next question will be to calculate work done during isothermal or adiabatic. There will be question to define zeroth law or first law, or simply statement of second law, that is Kelvin-Planck statement and Clausius statement. These statement. First law, statement of Kelvin, Clausius, these things. For numerical part, from this chapter, you'll be asked on the basis of first law. Let me give you a problem related to that part. This is pressure versus volume. A, B, C, D. Like this. So from this part, for process A, B, C, 100 joule heat is supplied to the system and work done on it is 30 joule. For ADC, work done by the system is 10 joule. Find first internal energy at point C if internal energy at point A is 20 joule. Second, heat supplied to the system in ADC. Try to solve, Samira. Samira, any problem while solving?
So can you show the first one?
Okay. According to first law, you'll say dq is equals to du plus dw. In the first process, heat supplied to the system is 100 joule. So heat supplied to the system is taken to be positive 100. Change in internal energy plus work done. Work done on it 30 joule. So it will be positive or negative, Samira?
Positive.
Work done on it. On it means on the system. Work done by the system is expansion and work done will be positive in that case. But work done on the system is compression and will be negative.
Yes.
Is it clear? So work done will be minus of 30 joule. So change in internal energy is 100 plus 30, that is 130 joule. Change in internal energy is state function. It will depend upon initial and final state only. It will be independent of path followed by the gas. So you'll say this internal energy will be internal energy final minus internal energy initial is equals to 130 joule. Internal energy for point A is given. Internal energy for point C we have to calculate. So 130. So internal energy at point C will be 140 joule. Is it clear?
Yes, sir.
Similarly, try to find the second part.
So internal energy for C will be 150, right?
Yes, I've corrected. Samira, got the answer for the second part?
Yes, I got. Is it 30 joule?
30 joule. Okay, let me just solve. dq is equals to du plus dw. dq we have to calculate. du is in change in internal energy, and change in internal energy for first part we have 130. So it will be 130 plus work done in this case is by the system. So it will be positive or negative?
Positive.
So plus 10. So total amount of heat must be supplied in this process will be 140. Is it clear, Samira? In this part, we have to take change in internal energy. And change in internal energy is state function which depend upon initial and final point only. So we can say initial point and final point for ABC is same as for ADC. That's why internal energy will be same for both these two processes. Is it clear?
Yes.
Next question will be from this part. to define CP and CV. Further, you'll be asked why CP is greater than CV and hence derive its relation. That is Mayer's relation. So Myra, any idea why CP is greater than CV? First, what do you mean by CP and CV?
It is heat at constant pressure and heat at constant volume.
Heat? No. It's molar specific heat constant.
Yeah, yes.
What do you mean by molar specific heat?
The amount of
Yes.
the amount of temperature or heat required to raise the temperature of the substance by 1 Kelvin or 1
Temperature of substance? No. In this entire chapter, we define only for gases, and the amount of gas will be just 1 mole. So it is the amount of heat required to raise the temperature of 1 mole of gas at given condition. So for CP, it will be at constant pressure, and CV, it will be at constant volume. Is it clear?
Yes.
So why CP is greater than CV? Since at constant pressure, the amount of heat supplied to the system is utilized in two different processes. First, to change internal energy of gas, and second, to do some work. So if you have to get same amount of change in temperature or change in internal energy for constant volume and constant pressure, you must have to supply some extra amount of heat at constant pressure with respect to constant volume. Since at constant volume, heat supplied to the system utilized only in changing internal energy. That's why it would require lesser amount of energy or lesser amount of heat to change by same amount. That's why CP is greater than CE. So Myra, is it clear?
Yes.
Okay. Next is you'll be asked to define process according to different curve. Let's say this is pressure versus volume. So one of the curve will be for expansion. This is for expansion. And this is for compression. So Myra, just tell me, what will be the process for 1, 2, 3, and 4? This is expansion curve. and this is compression, pressure versus volume. This is tell me about first, which process is isothermal, adiabatic, isoporic, isobaric? Which one?
Isochoric.
Isochoric. It means volume should be constant.
No, isobaric.
Good. So delta P equals to 0. Next, second. Tell me about fourth. What is constant here?
Volume.
Good. So it will be isochoric. For 2 and 3rd, we have to check its stiffness. So just draw tangent at its starting point, like this, or like this. So for these two different lines, if you try to calculate its inclination with respect to horizontal, which is more inclined or which having more stiffness, the upper one or the lower one?
Lower.
So greater the stiffness of curve, it will be adiabatic. So this will be adiabatic and this will be isothermal. Similarly, try to assign name of these different process. Fifth one is, in this part, volume is changing, but this particular point is constant for this entire part. So it will be isobaric, that is delta P equals to 0. In this vertical line, volume is constant, pressure is changing. So delta V equals to 0. Which one will be isothermal and which one will be adiabatic?
Seventh one will be adiabatic.
Just 1 minute. Good, Samira. If you draw a tangent to these two different curves, one of the tangent will be this, and the other tangent will be this. So if you calculate its inclination with respect to horizontal, so one of the inclination will be this, and the other inclination will be this. It means 7th is more steeper as compared to 6th one. So it will be isothermal and it will be adiabatic. So this particular curve is just opposite of this one. So just remember, in case of expansion, compression, these different curve will be like this. So next question, on the basis of area under PV curve, which is work done, if you have to calculate, so just draw shaded region around it. So from this part, you will see for isobaric, work done is maximum, then for isothermal, and then for adiabatic. But if you draw for this part, it is just opposite. Samira, is it clear?
So can you repeat?
In case of expansion, isobaric curve is at the highest point. So it will inscribe maximum area under pressure volume curve. So work done will be maximum in this part. Then next to it will be for isothermal, and next to it will be for adiabatic. For isochoric part, work done will be 0 since there is no change in volume. But in case of compression, isobaric is at the lowest point, so it will cover lowest area, then isothermal, and the most is adiabatic. Is it clear?
Yes.
Okay. So this is all about the different thermodynamical process. Next is on the base of heat engine, refrigerator, and heat pump, you will be asked to define or calculate on the basis of efficiency. According to the formula, eta is equals to work done divided by heat absorbed. Work done is Q1 minus Q2. So if you simplify it, you will get 1 minus Q2 minus Q1 and simply 1 minus T2 by T1. So there will be some problem related to these different terms. You'll be asked to calculate, suppose Q1, Q2, work done, or T1 or T2 according to efficiency. Is it clear, Samira?
Oh, for me, this part is deleted.
Oh, good. So the entire refrigerator heat pump is deleted?
Yes.
Oh, that's great. So this is all about this thermodynamics part. Okay, let's stop here. I have to take your Viva. Just 1 minute. Yes, Samira. Am I audible?
Yes.
Okay, how much you have prepared for Viva?
Not much so.
I think topic was wave.
Yes.
Tell me the topic in which you are more confident. Just define wave.
Like it is a propagation of disturbance from one point to another point without the use of energy.
Without use of energy. Okay. What are the physical quantity transmitted or transferred during this process? it propagates energy and momentum from one point to another without the displacement of matter particle from one point to another. Okay.
Yes.
Okay, next is just explain transverse wave.
When the particles of the medium vibrate in the direction perpendicular to the direction of propagation of disturbance, it is called.
Good. What will be the formula of transverse wave, velocity of transverse wave?
Root P by M.
T by N. That's
M.
mu. Mu.
Okay, okay.
What is mu here?
It is the length.
Linear mass density.
Yeah.
Mass per unit length. Why transverse wave can travel through solids only? Okay. Define Newton's assumption for longitudinal wave.
He thought that the process, or like he took isothermal process.
Okay, for propagation of longitudinal wave or the sine wave, sound wave. What will be the value of beta for isothermal process? Okay, what is Laplace correction to it?